After the discovery of natural radioactivity, humankind was able to study different ways to artificially produce new radioactive elements. Today, to talk about artificial radioactive elements, I invited Professor Mario Mariani, the head of the Radiochemistry and Radiation Chemistry laboratories at Politecnico di Milano.
Thank you, Elena. The discovery of artificial radioactive elements in 1934 was made with the Laboratoire Curie of the Institute of the Radium, where Irene and Frédéric Joliot-Curie were able to provide proof of the existence of radioactive phosphorus and nitrogen. To understand the importance of the discovery, we have to focus on atoms. Atoms, both stable and radioactive, both natural and artificial, are made of a nucleus containing particles called protons and neutrons, around which electrons orbit. The same chemical element could have several different nuclei. They are called isotopes. They could be stable atoms, radioactive atoms, or both. This is why elements' names and symbols are accompanied by a number. The number identifies exactly the isotope. Consider cesium, the element indicated as Cs. It exists in nature as a stable atom with a nucleus containing 55 protons and 78 neutrons, and it is indicated as cesium-133. However, another isotope of cesium could exist, having a little bigger nucleus that makes it not stable. It is radioactive cesium-137, where the neutrons become 82. However, cesium-137 does not exist in nature. It is produced in nuclear reactors or by nuclear weapons testing. In general, radioactive isotopes are also called radionuclides.
Artificially radioactive elements could be produced by means of nuclear reactions, achieved in nuclear reactors, in particle accelerators, or by the explosion of the atomic bomb. In particular, nuclear reactors can be considered one of the most efficient generators of artificial radioactive isotopes. How does this happen? By a process called nuclear fission, discovered by the German chemists Otto Hahn and Fritz Strassmann in 1938, thanks to research led by cooperation with the Austrian-Swedish physicist Lise Meitner. This phenomenon could be managed into a machine called nuclear reactor. They discovered that if an atom of uranium was struck by a bullet, a neutron, the atom would be broken into two smaller atoms, called fission products, and some neutrons would be emitted along with a huge amount of energy. The emitted neutrons could strike other uranium atoms and give life to the so-called chain reaction, in which a large number of nuclei undergo fission and an enormous amount of energy is released. So, when the fuel made of uranium is loaded in the reactor and it is hit by neutrons, nuclear fission starts and could continue in a controlled way. The result is the release of an enormous amount of energy and the production of a lot of artificial radioactive elements inside the fuel. All this happens in the reactor core. Let's be clear, this is not what happened in a nuclear bomb. There, the nuclear fission proceeds uncontrolled.
Radioactive elements can be produced artificially. That happens in particular in nuclear reactors by a process called nuclear fission. When an atom of uranium is broken into two smaller atoms by a neutron, and some neutrons are emitted along with a huge amount of energy.